Here we go with one more KSP problem. Different way of wording it at the start. PBI2 has a KSP of 9.8 times 10 to the minus 9. Our job is to calculate the concentration of PBI2, concentration of PB2 plus, and the concentration of I minus at equilibrium and saturation. So once this thing reaches saturation, what are the concentrations of all the species? This is very like those problems in the KC chapter where we had to calculate what are all the concentrations of everything at equilibrium. All right, so in this one, I'm going to set up the problem, the KSP, plug in the numbers that I have and the algebra that I get. So for PBI2, I'm going to do this without setting up an ice table. Once you get good at this, you don't need the ice tables either. When I do it this way though, I point out to myself as I work the problem that the concentration of lead is going to be X and the concentration of iodide ion is 2X. Those are the numbers I need out of the ice table. I don't need any of the other stuff out of the ice table. I just need to know what those are. And I can get those, if I'm careful, directly from the substance's formula. That means that KSP must be concentration of Pb2 plus and I minus squared. And that is a numeric value of 9.8 times 10 to the minus 9. So I plug my algebra in to my KSP. So I have X and 2X quantity squared equals 9.8 times 10 to the minus 9th, which, as I simplify that, we get 4x cubed, like we had before in one of our problems, equals 9.8 times 10 to the minus 9th. X cubed is 9.8 times 10 to the minus 9th divided by 4, which has a numeric value we can calculate pretty easily. 9.8 times 10 to the minus 9th divided by 4 equals 2.45 times 10 to the minus 9th. X would be the cube root of that number. So the 1/3 power. I get 1.35 times 10 to the minus 3rd. Okay, so that's my intermediate answer. I go back to my problem, we want to know about everything. What's the concentration of everything? Well, X, we said before, was Pb2 plus. So for our answer, concentration of Pb2 plus is X, which is 1.35 times 10 to the minus 3rd molar. And that also equals the concentration of PBI2, because there's 1 PB per PBI2, so those concentrations must match because their coefficients essentially match. So the concentration of PBI2 as a compound is X, and that's 1.35 times 10 to the minus 3rd molar. Concentration of I minus, we said at the start, was 2X. So that would be 2.70 times 10 to the minus 3rd molar. So those are the numbers we were looking for. The concentrations of all of the species that exist in that solution from PBI2 saturating the solution. So that's about as involved as the straightforward KSP problems get. Good luck, folks.